The next speaker is Dr. Walt Meier, formerly with NASA, presently back with NSIDC. He's going to talk about the long-term changes in the ice retreat and open water season in the Arctic, potential implications for operations in the region. And he's going to be perfectly on time.
Okay. Thanks, Pablo. I want to thank Pablo and John for asking me to present, inviting me to present. I'd like to think that the major reason for that is interested in hearing what I have to say. But as Pablo made clear at one point, he wanted a NASA scientist to give a talk. So I want to thank Pablo and John a second time for keeping me on the agenda after I let them know that I was going to be leaving NASA shortly before this symposium. So I am now at the National Snow and Ice Data Center officially. Before I get started, I guess I will, to fulfill kind of my NASA duties as an unofficial NASA news, because I'm not a NASA employee anymore, I'll just mention that ICESat 2 is coming along quite nicely. It's on schedule for a launch next summer. And IceBridge flights are, they're doing their summer campaign right now. They just started. So lots of cool stuff going on at NASA. And so I'm going to talk here about a specific project that I started with colleagues Mike Steele at the University of Washington, Angela Bliss, who's at Goddard and the University of Maryland, and Peng Gi at NC State and NOAA. And this is the goal of this is to look at some climate indicators for sea ice. So, what is an indicator? Just for those that may not be, probably most people are familiar, but the definition, it's something that we regularly updated. It's something that we can kind of get a good sense of what the ice conditions are or whatever climate conditions we're looking at, provides scientific understanding, but also geared towards informing decision-making and in meeting management objectives. So it's kind of distilling the science down into ways that can help decision-making. One of the things with a climate indicator, it needs to be consistent and continuous over a long period of time, and it's important that it be of high scientific quality. So one of the most common sea ice indicator, I'd say, is the sea ice extent. That's what you see most frequently. This is on the left is the yesterday's sea ice extent and total extent for the Arctic. We're tracking pretty close to 2012 levels right now. And then on the right is the September monthly average. Again, I'm sure you've seen this many times in the long-term declining trend. So this is very useful information. The goal of our project is to see how we can expand on this and go beyond this and provide new information that can provide new insights. Before I do that, I want to comment on these are based on the passive microwave sensors, and the indicators that I'm going to be talking about next are also based primarily on the passive microwave record. And so I would just want to take this opportunity. Again, many people may be familiar with this, but our passive microwave sensor record is I would say, at risk. We've had a long series of the DMSP Defense Department satellites, the F-series, and those are now aging and getting quite old. We're also looking and using AMSR 2 from the JAXA, the Japanese Space Agency, and that also has gone beyond its mission lifetime. These usually last a fair amount of time, and so hopefully there's not any immediate threat. But if you look out into the future, you'll notice that there's really nothing much planned until the early 2020s. So we're hoping that these satellites will last. There are some other potential stopgap measures we could use, but this is kind of the foundation of our one of our major sea ice climate records. And if we lose this, we'll lose at least some of the quality of that record. So Looking at the sea ice extent, sea ice indicators, again, the goal of this project is to develop new indicators that go beyond extent. To give us a little more detail on the sea ice cover, more insights into the seasonal evolution, give us some better indication or different indications of the weather and climate processes that are affecting the sea ice, something that has more regional and local applicability beyond just an Arctic-wide total extent, and also something that perhaps has more relevancy for stakeholders. So just to quickly summarize the data, again, like I mentioned, this is passive microwave based. We have a couple melt onset data sets, which is basically using thresholds of passive microwave frequency, brightness temperatures to detect when the surface melt on the snow on the sea ice occurs. One, the Anderson et al. Product, it's archived at NSIDC, and one at Goddard by Torsten Marcus and others. And then the sea ice concentration data set, the climate data record developed by NOAA and NSIDC. So as we developed the indicators, we kind of looked at this and looked at the summer sea ice cycle and wanted to see, how could we capture the typical cycle. You're starting out in winter, you have the early onset of melt, the snow starts melting, then you get surface melt, then it forms into the ponds, and then the ice starts thinning and breaking up, and then you have your open water season until the late summer when you start to freeze up in the growth season. So Mike Steele came up with the idea of kind of tracking the stages of this by looking at the ice concentration. So you have an opening when the concentration drops below 80%, then what we call the retreat when it drops below 15%, which is essentially the open water definition in the passive microwave data. That's the minimum concentration that is detected. And then in the freeze-up stage, you have what we call the advance, when you first start ice forming over 15%, and then closing when you get into the consolidated ice pack greater than 80%. And so we have periods here. The range between the opening and the retreat is the summer loss of ice period, or slip. And then in the end of summer, the range between the advance and closing, the summer growth of ice period, or SGIP. And then we have open water periods. This is the outer open water period is where we have really any open water or any significant open water detected. And then the inner open water where it's essentially completely ice-free, at least as detected by the passive microwave data. And I'll make a point here, like I said, we're using the passive microwave record. There are, I won't go into the details, but of course there's limitations of the passive microwave, and there's different algorithms. And for example, the operational analyses may be somewhat different in what they detect and how they define the ice cover. But the thing is, with this method, you could use different data sets and do the same type of analysis, and that's something we're looking at doing to compare these. So this is just an average. We have these for each year, but I'll keep it simple. This is the opening. We can make maps of these. And it may be a little bit hard to read this, but this is March through December with the different color shading. So you get a lot of the opening that is occurring here in the August period. And really, some of this it may not really open much at all. Then this is retreat, and then you end up into the advance, and then the closing. So you see the regionality there. You can see the maps that it kind of generally comes from the north or from the south to the north, and then back the seasonal cycle. But you can look at those, and then if you then look at the ranges, the slip range and the SGIP in the open water periods. Again, making these maps, you can see some interesting features. Again, you lose that somewhat of that north or south to north because you get the difference in how much the ice from when it starts to open up to when it completely starts to where it completely retreats. Like in the Beaufort here, there's this area here that basically stays around longer. The darker colors being a longer time period. the Greenland Sea, where you get some opening, but it of course usually doesn't clear out completely of ice. And so this gives a sense of how the ice cover and the variability over the ice. So these are nice, but we want to look at a way of distilling this even further to inform again decision making, something that can be kind of looked at a glance. So Angela Bliss, who's here, came up with this. I think this is a really interesting way of looking at things. Again, when we were trying to find a way to distill this down, we're kind of trying to brainstorm ideas, and Angela came up with this. And it's basically taking this and kind of looking at the areas that open up, and then basically plotting these sequentially. So this is time going forward in years, going up from 1979 to 2015. And then this is across the calendar year, January to December. So this is for the total Arctic. We have 3 different melt onset products, actually, or parameters. Like I said, there's 2 products, and the Marcus, the NASA Goddard product, actually has 2 melt onset. There's an early melt, and then there's a continuous. And so the early melt is when we first see any sign of melt, and then the continuous melt's when it's basically going continuously. There's no diurnal effect or anything like that. So so you see that, and you'll notice that there's even the early and the continuous and the red and the green compared to the AHRA, or the Anderson and Bliss, the NSIDC product. There's quite a bit of difference, upwards of a month difference, and that's something that we're looking at. Angela has a very nice paper, Bliss et al., in 2017 that goes into details of why that is, and it's basically different sensitivities of the algorithm to the changes in the passive microwave signal. But you can taking that, you see the melt, and then you have the gap, the length between the melt and when it starts to open, crosses the 80% threshold, and then that slip period in the light blue till you hit the open water, and then you hit the freeze up, where you get the 15%, and then the gray is the escape period. So this gives us basically in a snapshot the complete evolution, summer seasonal cycle of the sea ice. And again, this is over the total Arctic where we have open water in each year, and so you can do this over different regions. The Arctic is maybe not the most important region, but first, another way of looking at this is kind of looking almost like an anomaly, where we center it on the center of the open water period, so you kind of get a sense of a better sense of how long the open water period is, in kind of more of a better, perhaps a better relative sense. So that's 2 different ways we've put together of looking at this. But again, the total Arctic is maybe not the most interesting area. So we can do this for subregions. I got a little messed up there, but the title. But this is the Beaufort Sea. Here's the regions here. The Beaufort here in the orange. It's a little hard to see there. But you can see there's quite a bit of variability in the timing and the length of these various seasons. I think that's one thing that just shows really nicely. And that has perhaps implications for sea ice forecasting, how well you can do that. And sometimes it's early, sometimes it's late. Some of the open water period is quite long, like in '96. Sometimes it's quite short, like in '85, I think this is. So this gives us again a nice kind of a different way of looking at things. And this is the Beaufort Sea. This is the Chukchi Sea. So you can see the contrast there between the Beaufort and the Chukchi, even though the Chukchi is right next to it. Much longer open water season because of the way of the ice melt, and the way the ice dynamics as well plays a role in that. But again, some variability there. And then again, we can look at these from the centered. And again, you see maybe a little bit more clearly here the variability in these different seasons between the 2. That's the Beaufort Sea, and then the Chukchi Sea. And again, we can do this for any of these regions here, or even hone in on even more local areas as needed. For example, if we wanted to look at just kind of the Beaufort or the Barrow region, for example, that would be something that's of relevance to stakeholders, perhaps, or certain sub-regions of the Chukchi Sea where you're maybe looking for access. And do these same types of things, same types of plots. So what we're planning to do is to implement this more fully. Eventually, we will put this out on website, probably at NSIDC, and this will be available hopefully before too long to interested users. And then we can tailor this potentially to specific users fairly easily, add on different specific regions, and so that's the goal of this. Just because I'm formerly of NASA, I want to make sure I mention again, or I mention if I didn't, that this is a NASA-funded project through the Climate Indicators Program. So I'm going to switch gears just slightly at the end, take a couple minutes on another climate indicators project that I've been involved with. This is actually a special issue for climatic change. It's a special issue on national indicators of climatic changes. We have a large group of us led by Diane Stanitsky and Janet Antreri at NOAA, leading a review paper essentially of the sea ice, the existing sea ice climate indicators, and also the climate indicators that are needed and to fulfill gaps. And one of the ways to do this is to have a conceptual model and look at all the interactions in the sea ice and the rest of the Arctic climate system. Because what we're looking for in these climate indicators is not only beyond sea ice extent, but beyond sea ice, to look at Arctic-wide climate indicators and looking beyond just the physical indicators, which is what's been most commonly developed, but also the biological, social, and economic indicators to help basically tie these all together. So we have this conceptual model, which is based on an NSF report. And I think we've tweaked this a little bit more. But Martin, you'll be happy to know we do have a person in there. And that was one of the things as we've been discussing this and discussing changes. One of the things that we got to make sure we keep a human in there, because that's a key part of this indicator effort. Is we're serving the human communities and the social aspects, not just looking at physical indicators. And then also looking at global, pan-Arctic, regional, and all the way down to the community level. And so, we're kind of reviewing these, looking at what's currently out there, currently available, looking at what's in development, basically what's kind of being developed. It's just not quite an indicator yet. Things that have been proposed, such as the project that we're working on, and then more aspirational, where things like we really could use an indicator here, but we don't have that. We don't even maybe have the data, but can we get the data, or how could we get the data? So that's the goal basically, is this review paper will help inform that and perhaps get discussion and help spur on the needed climate indicators. So just a quick summary. The indicators are helping us summarize and synthesize complex data. They're giving us concise information, kind of distilling things down in ways that can really help decision making. Also help visualize and communicate the climate change and identify kind of the processes that are important or maybe most important and potentially help develop mitigation and adaptation strategies. And again, at the end, it's important to have these very scientifically validated data, regularly updated and continuous. And of course, the bottom line is you want it to be value to the user communities. You don't want to do something that's just for your own scientific interest or whatever. So with that, I will finish.
Thank you, Walt.
There's time for questions. And let me, my final comment here, my shameless self-promotion, since there's a lot of sea ice folks here, if you're thinking about submitting to AGU, if you only submit one abstract, I would highly recommend that session that I'm co-convening.
My final comment to you is no questions for you.
Oh, okay.
But if anybody wants to, they can catch you at the break.
Okay.